Hello Skyhawks, and welcome back to another episode of SIP Zoyus, your semi-daily dose of math curriculum. Our topic for today is going to be graphing features of parabolas, and so we're going to have a handful of features about a parabola that we're going to be looking to put onto a graph. So, parabolas have many features which can be graphed, and they're the following: the axis of symmetry, the directrix, the focus, the x-intercepts, the y-intercepts, and the vertex. We can see examples of each over here. Right, our x-intercepts are on the x-axis, our y-intercepts on the y-axis, the axis of symmetry perfectly splitting our parabola, our focus centered above our vertex, nestled in the curvature of the parabola, and our directrix lying on the other side of our focus, below the vertex. So, let's go ahead and start finding these features and graphing them. So one small thing to note is there's a lot of different skills that we're going to be employing here, and I've included the equations for each of these features that we're going to be finding. Definitely understand that if you're having difficulty finding any one of these features, you might want to go back and work just on that feature because they are kind of an independent set of skills. So without further ado, let's go ahead and start finding some of these features. There's no real order that you have to find these in. Some orders may make a little bit more sense than others, but for the most part, you can start kind of wherever you would like. So I'm going to go ahead and start with my y and x intercept. So I know that my y-intercept will be when x is equal to 0. So I'll go ahead and take my equation from up here and substitute 0 in for x, so I'll have y equals 1/4 divided by 0 squared, or divided by, times 0 squared, plus 2 times 0 plus 3. 0 times that is just going to go to 0, and 2 times 0 is also going to go to 0, so that's going to leave us with 3. So we'll have 0, 3 for our y-intercept. And now for our x-intercept, we're going to go ahead and plug in y equal to 0. So y will be equal to 0. And so we're going to say 0 equals 1/4 times x squared plus 2x plus 3. Now there's a handful of ways you can go about solving this. You can use the quadratic formula. You can complete the square. And you can also do factor by grouping. Factor by grouping is actually going to be the quickest way to go about this, so that's going to be the method I'm going to use here. So doing factor by grouping, the first thing I'm going to do is get rid of this fraction. I can multiply by 4 on both sides, and that'll just make this problem a little bit easier. So multiplying by 4 on both sides, we'll have 0 on the left equals x squared plus 8x plus 12. Okay, we can now go ahead and do factor by grouping, and the little acronym that we have to remember that is the MAGIC acronym, standing for the magic method. And we want to first multiply a times c. So a times c is going to equal 12. 1 times 12 is 12. And then a is going to stand for b, which is because we want to add to b. So we want to add to this middle term, which is 8. So our game is now that we want to find factors of 12 that are going to add to 8. Thinking about it for a little bit, we're going to realize that 2 and 6 will do the job just fine. So then we're going to want to take these factors and separate our 8x based on 2 and 6. So we're going to want to write 0 equals x squared plus 2x, right? We separate it into 2x plus 6x plus 12, just like that. Now we want to go ahead and group with our g, right? G stands for group. So we want to group the first two terms, and we want to group the last two terms. After grouping these, we now want to do the IC, where we pull out in-common factors. So our in-common factor for our first grouping is going to be x, leaving behind x plus 2. Our in-common factor for our second grouping is going to be 6, so 6 leaving behind x plus 2. Now we see that x plus 2 is our shared factor, so we can pull that out. And left behind is x plus 6. Okay, and this is pretty easy to see what our solutions are going to be. We'll have a solution of x equals negative 6 and a solution of x equals negative 2, since those will respectively zero out each term, meaning that our x-intercepts are going to be negative 6 comma 0 and negative 2 comma 0. Alright, so let's go ahead and let's plot all these points. So we have negative 6 comma 0, we have negative 2 comma 0, we have 0 comma 3, so up here, and that is that. So those are those 3 points, and now we can go ahead and we can start looking for our vertex. So realizing that we have a vertical line, and if you weren't sure about this, we realize this because we have a square on the x. Realizing we have a vertical line, we want to go ahead and see that b divided by negative 2a will equal h, the x value of our vertex. So we can go ahead and calculate that. So negative b divided by 2a is going to be equal to h, or the x value of our vertex. And so b is going to be negative 2. Well, b is 2, but we plug it in and we have negative 2. And then 2 times a is going to be 1/4 here. So the 2's are going to cancel out, and the 4 we can multiply by the reciprocal of 1/4, which is just 4, and that's going to give us negative 4 for h. So h will be negative 4, or the y value for our vertex will be negative 4. Now we can take this x value and plug it back into our equation to see what the y value for our vertex would be. So we can take this and we'll plug it back in. So y, or in other words k, is going to be equal to 1/4 times negative 4 squared plus 2 times negative 4 plus 3. So doing the math, we have negative 4 squared, which is 16, divided by 4 is going to bring us back to 4, plus negative 2, which is going to be, or 2 times negative 4, which is going to be negative 8, plus 3. Then adding those all up will bring us to a negative 1. So our k value is negative 1, so our vertex altogether is negative 4. Oh, sorry, the math is down there. Our vertex is negative 4 comma negative 1. Okay. Now that we have our vertex, it's pretty easy to go ahead and find our axis of symmetry. So again, we have a vertical parabola, so that means that our axis of symmetry is going to be x equals h, or x equals the x value of our vertex. So our axis of symmetry will be x equals negative 4, because that's the x value of our vertex, and that makes sense because that would be this line right here containing all the values of when x is equal to negative 4. And that looks good because it looks symmetrical. Okay, so now on to the very last thing, the focus and directrix. So this might be the most challenging part of it, because what we're going to have to do is we're going to have to complete the square. And the reason why is because we need to figure out what p is equal to. And the only way we can do that is if it's in this format. So we want to go ahead and complete the square to then get it in this format. So clearing some space down here, we want to go ahead and start to complete the square. And so realize completing the square is a skill in itself. If you're not sure of that, just take some time to research it. So we want to go ahead, we're going to be starting off with y equals 1/4 x squared plus 2x plus 3. Alright, so we start off with this. We want to go ahead and get it into format so we can complete the square. So we want to subtract 3 from both sides. That's going to bring us to y minus 3 equals 1/4 x squared plus 2x. So we're almost there. Now we want to get rid of this coefficient on our x term, on our x squared term. So we'll multiply both sides by 4. Distributing on the left, that's going to give us 4y minus 12 equals x squared plus 8x. So the missing square term that we want to add is going to be b divided by 2 squared. b is equal to 8 here, so we want to do 8 divided by 2 squared plus 8 divided by 2 squared. That's going to give us 4 on the left side, 4y minus 12, and 8 divided by 2 will be 4. 4 squared will be 16, so plus 16 is equal to x squared plus 8x plus, and instead of writing 16, I'm going to write 4 squared. This is now in binomial format, so we can then go ahead and factor this into x plus 4 quantity squared. And on the left side, we then have 4y plus 4. So we're almost into translational format, right? We almost are resembling this format. Again, we want to match the vertical format because we have a vertical parabola. And the last thing we need to do is we just need to get this factor off of 4, or this multiplier off of 4. So we can factor out of 4, and we'll have y plus 1 left over. And voila. We have our terms. We have our equation, in format. And so it's now easy to see what p will be equal to. So we notice that 4p is the multiplier in front of our y term right here. So all this here needs to be equal to 4p, which we actually might not even have to do math for that, but we can just say that 4p needs to equal 4, which means that p will have to equal 1. So our p will equal 1, and so our vertex, our focus, right over here, is going to be our vertex plus p. So p is 1, so we want to go to our vertex, and remember, you want to ask yourself, are we going to be moving up and down, or left or right? Remember, the focus is always going to stay on the axis of symmetry. So in this case, we want to move up to stay on our axis of symmetry. So we're going to move from our vertex plus p. So p is 1, so plus p brings us to right there for our focus. So our focus is going to be -4, -1 plus 1, which equals -4, 0. And we see that's the point that we graphed, -4, 0. Now let's go ahead and find our directrix. And our directrix is going to be our vertex, so -4, -1 minus p, so -1. And again, we're going to subtract this from the y value because our parabola is vertically oriented. So we'll have -4, -2. And remember, our directrix isn't going to be just a point, though we can start off by plotting this point. But remember, our directrix is going to be all the points on a line below our parabola. You can actually think of our directrix intersecting at that point with our axis of symmetry. So our directrix is going to be the equation of y equals -2. All the points where y is equal to -2, and we see that right there. So last but not least, let's go ahead and put the icing on the cake and connect our dots to show our parabola with all of its key features clearly laid out.